My name is Jeff Hamlin with FieldView, and today I'm going to show you how FieldView, combined with Greentronics, can help you get information about every pass that you make through the season in any sort of field that is potato, sugar beet, carrots, onions, grapes, tomatoes, really anything that is harvested with a truck where the harvester goes across, the crop is moved across a conveyor belt and into a waiting truck in the field in real time. We'll go over how all that works in just a minute, but I'm going to just start with a potato field. We're going to focus on potatoes largely today and show you how this works and the kind of information that's gained. FieldView is a system that's on 200 million acres here in North America. It's being used in 23 countries, but it's a way for farmers to collect and analyze their data from pretty much anything that they drive across the field. We have a device called the FieldView Drive that plugs into pretty much any tractor, sprayer, spreader, combine, harvester, and allows you to do what you're already going to do, which is make those passes across the field and collect the data live into an iPad, regardless of make or model or brand of the piece of equipment driving across the field. It doesn't matter if it's John Deere, Case, New Holland, Trimble, Raven, Ag Leader, Bourgault, whatever it is. Almost inevitably, our system is going to be able to talk to it and collect that data in real time. So what we're looking at here is a planting map where the grower had our system plugged into his planter, and we can see what the result is. We can see that he was planting russet Burbank potatoes. We can see where those were planted. We can see where Ranger russets were planted in this field. And this is a variety map that was collected live in the field just by the grower making his planting pass. Now, while he was planting, we are also monitoring population. What was the seeding rate that these potatoes were going down at? And you can see where some of those seeding rates changed a little bit. We can look at our planter speed and say, hey, how fast were you driving? Were there parts of the field where you were driving faster than others? And how might that impact yield at the end of the season? The idea is to be able to collect all these maps so we can understand why different parts of the field might have yielded higher or lower. We can then go in and also say, hey, what else were you doing? You were putting down 326 as a fertilizer, and it looks like you did it at a pretty uniform rate, but this is the map of the 326 fertilizer that was going down with the planter. And then also when he was planting, he was putting down some stuff in furrow. He was doing a comparison of A-frame, and I can see where the A-frame went down in the field. And I can compare that. He was comparing that to a product called vellum, and we can see where the vellum went down in the southern part of the field. And so what he was looking to do is say, hey, I've got these two products. I want to compare them. I want to see if there's a yield difference between using these two. And I'm going to show you how that works out at the end of the season in just a minute. We can also go back here and, he was doing various spray passes throughout the course of the season, and you can see all the different spray passes that he did here. If I pull up one of these, I'll just show you in detail what it looks like. He does the spray pass. We can see where where that sprayer went. We can see the rates that were applied. But from a data audit perspective, if you ever need to get someone information about what you did in that field, having handwritten notes on a notebook that might not be able to find when you need it is not the way to go. You want to have a digital record that can easily be shared with anyone, whether it's your agronomist, your brother-in-law, your landlord, or an auditor that might need to see some of your records. And FieldView does a really good job of this. I'll show you, just by making this spray pass, you automatically get a little 1 or 2 page PDF that has all the information that an auditor might need to know. It says, hey, this field was sprayed, if you look at the upper right-hand corner, between July 3rd, or on July 3rd, between 9:18 and 11:04. It's a potato field that was planted on May 23rd. Here's my coverage map that shows my rates. And then here's the products that were in the tank. It will automatically tag any product with the EPA registration number, so you have that as necessary. It'll show you from the rate controller of the sprayer what the actual rates of each product were that went out, the average rates, and the total number of pounds or gallons or pints or ounces of product that was used on that field. It'll give you the piece of equipment that did the pass, the operator license number, acres, gallons applied, and it'll automatically tag things with the wind speed, wind direction, and temperature at start and stop of spray. So everything that you would need to provide to an auditor to be able to get through an audit and show him exactly what you had done on that field. So this is just, again, something that shows up automatically by you doing what you're already planning on doing, which is driving the sprayer across the field. You don't need to move thumb drives. You don't need to, be some sort of IT person. It's just going to show up automatically by driving across the field because our system is listening to the GPS of your machine, so it knows where you are. It knows how wide the boom is. It knows how many sections your sprayer has, and it knows and you're telling it what the product is in the tank, and it's reading rate off of your rate controller. So that's kind of what a spray report looks like. But the cool thing about this is our system ends up generating this season summary that is every pass that you made across this field all season long. And this is the diary of that field for the season. So if you need to share data with a landlord or your brother or your agronomist or whoever, it's very simple to, at any point throughout the season, say, hey, N22, my field N22. This is the season summary. This is every product that was used, every pass that I made, every EPA registration number that was associated with something, every, the total number of ounces or gallons of every product that was used, every piece of equipment that went across that field, total acres applied. This is the story of this field all the way down to harvest at the end. That's going to tell us what our yields were. So this is the diary of that field for the season. And again, just generated automatically by plugging our system into whatever piece of equipment you're driving across the field and monitoring every pass. Let's continue on here and let's go to the harvest part of this, because that's kind of the cool thing that most guys have never seen before, especially when we're talking about potatoes and sugar beets and onions and carrots. This is the yield map, and this is where the Greentronics system comes in, and I'll talk more about that in a minute. But basically, Greentronics has built a system that allows them to calculate instantaneous yield as the harvester is moving across the field. We've built a system that has a nice front-end view that allows you to display that data and create it in a map that looks like this, and also run some pretty cool analysis. So if I look at this map, when I work with most potato or sugar beet growers, what they tell me is, I know what my field made. It made X tons. And I know how big the field is, so I know how many acres the field is, and I can calculate my average that say, hey, my average yield in this field is 27 tons. But what I don't have is the spatial variability. I don't know how the northeast corner did versus the southwest corner of the field. I just know what the average production was because I ran everything across a scale, and I know how many total tons came out of the field. This is the next level of sort of yield analysis. This is a spatial yield map. It's showing me in dark green the parts of the field that yielded higher, and in red the parts of the field that yielded lower. And I can start to see, hey, where are my better parts of the field? Where are my worst parts of the field? I probably have a gut feel about those anyway if I've been harvesting and working in this field for several decades and generations. But now I can actually see it on a map, and I can quantify it in some pretty cool ways. If I go in here, I can say, hey, tell me about yield in a part of the field. And maybe I say, this part of the field isn't yielding as well as the rest. How bad is it compared to everything? And wherever I draw a circle, it's going to tell me about that specific yield. It says I drew a 7.7 acre box or circle here, and the average yield is 27.54 tons in those 7.7 acres. Okay, let's compare 27.54 to a better part of the field. Let's do that same circle over here where I can see more green. Instead of 27.54, my yield in this part of the field is 34.9. That's a pretty significant difference. That's a 7.5 ton difference in yield between the eastern part of this field and that northwestern part of the field. When I can start to quantify this information and see how my yield varies through the field, I can start making decisions that are going to increase profitability. I can start thinking about, hey, should I be varying my fertility or changing my seeding rate? Or is there something wrong in that northwestern part of the field that if I added more lime or I did some soil amendments, I could fix it and make it look more like the eastern part of the field? Once you have these spatial yield maps, you can really start to hone in on how you can make your operation better by putting the right product at the right rate in the right place. Now let's go ahead and look at this was that field where we had that trial of vellum versus A-frame, and let me show you how our system helps you run those kind of trials and get to results. So if I go in here and I click planting and I let's pull up the A-frame map first. So I can see where the A-frame went down. I can see it next to the yield map on the other side. I could try and eyeball it and say, hey, does it look like the yield is better in the north half versus the southern half? It's kind of hard to tell. There's some noise in these yield maps. So we just make it easy for you by allowing you to come in here and say, I'm going to go ahead and create a field region here where I'm just going to select let's select these first 3 passes of the planter. And when I select them, it's going to go over and take the corresponding GPS coordinates from the yield map and tell me what my yield is associated with those 3 passes where I used A-frame in furrow. So I click done here, and those 3 passes, it's going to tell me you made 29.24 tons an acre in that 1 acre that's associated with those 3 passes. Okay, 29.24 tons an acre. Let's see how that compares. Let's pull up the vellum map, 29.24 for A-frame. Vellum, I'm going to go over here and pull up my vellum map, take these 3 passes, the next 3, because they're right next to it, so we're minimizing the sort of field variability there. Instead of 29.24, I get 33.83. So that's a 4.5 ton difference. Now, I'm not sure that it's caused by the vellum versus A-frame. There might be some soil type changes there. I mean, these are right next to each other in the field. They're pretty close. So, I don't know for sure that it's this, but if I run this trial again and again in a couple of different fields, and every time I do it, I always see a 3 to 5 ton benefit to the vellum versus the A-frame, well, then I can start to believe that actually that product is better. That product is causing a higher yield, and maybe I want to do more of that, and maybe I want to do less of the A-frame. But this is the kind of cool stuff that you can do when you have spatial yield maps. You can run trials of whether it's population, fertility rates, an in-furrow product like this. You can do A/B testing of product A versus product B, check strip versus product A, and get it through to a numeric result that's going to tell you what is the right thing to do going forward. Okay, let me show you one more potato field just because it's kind of, just to kind of go a little bit deeper on this and what these spatial yield maps do for you. Here's another one where I'm able to pull up, if I look at the potato yield for that field, here it is. This guy probably knows that the eastern part of the field doesn't yield as well. There's a shallower soil over there. He doesn't have the soil depth that he has in the rest of the field. And he's like, I always know the eastern part of the field yielded worse, but I never really was able to quantify how much. Well, now we can, and super easily. I can come in here and just say, hey, let's go ahead and draw a circle somewhere over here, like the normal part of the field. What's our yield? We're making 28 tons an acre in the kind of the core part of the field, 28 tons. How does that compare to this part where I can see that the yields are significantly worse? Instead of 28 tons, we're making 17 tons an acre. That's an 11-ton difference, and certainly a different level of profitability. In fact, we may not be able to make a profit where we're making 17 tons of potatoes an acre. So this gives the farmer the information to start thinking about it and saying, hey, next time I plant this field, next time this rotation comes up to potatoes, is it even worth it to put potatoes into that area? And I can see exactly where the boundaries are. Maybe next time I plant it, I use this map as a template and I only plant to the edges of where I see that the yield is just not worth it and I can't make a profit. Or maybe there's something I can do again from a soil amendment perspective to make that eastern part of the field better. But I now have quantitative information to help me understand how good the good parts of the field are, how bad the bad parts of the field are, and start thinking down the path of what decision can I make to increase my profitability next time I come back to this field with potatoes. Okay,